Hello everyone. So today we are going to see a passage-based question that came in IIT JEE 2008 exam. This question is related to passage, means there is a one passage, 5-6 line passage, and on that passage there will be 3 to 4 multiple choice questions. So the passage is as follows: the nuclear charge Ze is non-uniformly distributed within a nucleus of radius r. The charge density rho of r, that is charge per unit volume, is dependent only on a radial distance r from the center of nucleus as shown in the figure. The electric field is only along the radial direction. Okay, so what is given is over here is there is a nucleus, and of course we always consider nucleus as a spherical thing, and this nucleus has a radius capital R. What is happening over here? Look at the graph. On the x-axis, we are plotting a distance from the center of this nucleus. On the y-axis, we are plotting a charge density. Till the radius a of the nucleus, the charge density is constant, which is d. And from a to r, the charge density is varying with respect to r. From a to r, the charge density is decreasing from d to 0 as it reaches to the radius of the nucleus. Okay, so this is what is happening over here. So if I want to represent in this nucleus, it will be like this. So till the distance a, so if this is the radius a, the charge density over here is constant, which is d, and for this distance a to r, the charge density is varying like a straight line. So it will also have some equation, something constant and 1 minus r by r. If you work out the equation of this straight line, it will be something like this. Okay, so let us move towards the questions. The first question is, the electric field at small r is equal to capital R, that is electric field at radius r of the nucleus is. And there are four options, whether it is independent of a, whether it is directly proportional to a, proportional to a square, inversely proportional to a. Now remember the Gauss's law that we saw in previous questions in this electrostatic series. What we do whenever we have to find the electric field at particular distance from a charge distribution, we draw a Gaussian surface at that point. So what we will do it over here, we will draw a Gaussian surface at the radius r of this nucleus. So if this is the Gaussian surface, then what is the Gauss's law tells us. Then what is the Gauss's law tells us? It is E bar dot ds bar, which is nothing but a flux, is equal to Q upon epsilon naught, where this Q is the total of all the charges that is confined in this Gaussian surface. Means whatever the charge is over here, that will be this total charge Q. And of course, whenever we will integrate it over the entire sphere of the Gaussian surface, entire surface area of the Gaussian surface. Okay, in that case, what we want is total charge. It does not depend upon how the charge is distributed inside the Gaussian surface, whether it is uniformly distributed, non-uniformly distributed, or whether it is a point charge. So it doesn't matter whether the distribution till A is constant, like given in this graph, or it doesn't matter it is non-uniform it over here. What matters is total charge Q, and which is ZE as given in the passage. So of course, electric field at R is equal to R will be independent of A. Okay, so let us move towards the second problem. The second question for this passage is, for A equal to 0, the value of D is, the maximum value of rho is as shown in the figure. So first what we will do, the figure or the graph that was given over there, we'll just copy that graph. And now what we are going to do it over here is, that we are making a equal to 0, or we are bringing this a towards this origin. Okay, and once we do that, how our graph will look like? After making a equal to 0, graph will look like this. So R, rho of R, so there won't be any constant part of charge density, and charge density will look like this only. Okay, so what is happening over here is charge density is maximum at the center of the nucleus, and as you go away from the centers towards the radius, the charge density is decreasing in a straight line fashion or linear fashion. Okay, so what is the charge density, or what is the rho of R in terms of R? It is just the equation of the straight line. And we know this straight line is making two intercept on x and y axis. The intercept on the x-axis is R, and intercept on the y-axis is small d. And we already know what is the form of equation of straight line when two intercepts are given on x and y-axis. It is like this, where A is the intercept on x-axis and B is the intercept on y-axis. Okay, and for our graph, the x is small r, A is capital R, y is rho of r, and B is nothing but small d, which is intercept on the y-axis. Okay, so we will find rho of r from this equation as small d 1 minus small r upon capital R. This is our rho of r. Okay, we will proceed further to solve the question. Now, what is this question says? We have to find what is d over here. And what we have the formula for charge density. And also, we know what is the total charge. From the passage itself, the total charge is, what is the total charge? What does passage say? The charge is ZE. The total charge is capital Z E. Okay, we can use this. The formula for total charge is nothing but integration over charge density into dV. dV is a small volume. Okay, this is how we calculate the total charge, right? We integrate charge density over the volume of the charge distribution. Okay, and what is dV? From the previous electrostatic problem we solved, the dV for spherical polar coordinates, the dV is nothing but a thin spherical shell with a volume of 4 pi r square dr, and of course it will travels from 0 to r. Let us substitute rho of r over here. It is d. So yes, it is integration 0 to r. This 4 pi d will be common. This d and this 4 pi will be taken common, and what we will have, r square 1 minus small r by capital R dr. Okay, so we will split this term, and finally we will have 0 to capital R, r square dr plus 0 to capital R, also 1 upon r factor will be there, and it will be r cube dr. Okay, we know these integrations are straightforward. R square's integration is r cube by 3 from 0 to r, and r raised to 3 integration is nothing but r raised to 4 by 4, and this 1 upon r is over here, and this is also from 0 to r. So finally we will get 4 pi small d r cube by 3 plus r raised to 4 by 4r, and we know this 1r will get cancelled with one of the r, and so we will have r cube by 4. And one more thing, I missed a minus sign over here. This should be minus because this is minus. Okay, so let us do minus over here also. Okay, now this is nothing but 1 upon 3 minus 1 upon 4 after we take r cube common from this bracket. So 4 pi d r cube 1 upon 3 minus 1 upon 4, which is nothing but 1 upon 12. So 4 pi d r cube by 12 or pi d r cube by 3. Okay, and what is on the left hand side? It is ZE. Now we can get a value of D that is required in the problem. So 3ZE upon pi r cube is nothing but D, and which is in option, what was the answer again? 3ZE upon pi r cube. So second option is correct in this case. Let us move towards the third problem. The problem is as follows. The electric field within the nucleus is generally observed to be linearly dependent on R. This implies what? Okay, now if you are clever over here and you know the formula for the electric field inside a sphere with charge distribution constant throughout the volume of sphere, means if we have a sphere over here and the charge distribution is constant from 0 to capital R, this is constant, and if you remember the formula, because of this charge distribution, the field at a point outside the sphere is nothing but E outside 1 upon 4 pi epsilon naught, whatever the total charge on this sphere. Okay, for this nucleus, the total charge is ZE upon R square is the electric field. And if you remember, the field inside this sphere is nothing but for R less than R, the field is nothing but inside 1 upon 4 pi epsilon naught small r upon capital R cube. These are the standard formulas. And of course, we can easily derive this formula using the kind of uh, concept we used over here also. That just we have to put rho of r as constant. Okay, so we will get this formula for the electric field inside the sphere, and of course we will have also have to use the Gauss's law. But in general, it is beneficial to remember this formula. That is, if the distribution is uniform, charge distribution is uniform, then the electric field outside the sphere and electric field inside the sphere. Okay, so we can see for electric field outside the sphere is inversely proportional to r square, and electric field inside the sphere is directly proportional to r. Now let us come back to problem. What problem says? The electric field within the nucleus is usually linearly dependent on R. That means electric field inside the nucleus is usually proportional to R. That means exactly like this formula, where electric field inside a uniformly charged sphere depends on linearly on R. So, and when this is true, when the charge distribution is constant. And therefore, when the charge distribution is constant, the electric field is dependent on, linearly dependent on R. That means charge distribution should be constant. Now, when we go back to our figure, this was like this figure, where this was D and this was R, this was A. For our case, for this to be true, the electric field should be constant throughout the distance of this r. That means this linear pattern, this linear decrease of the electric field should not be there. Or in short, from 0 to r, this is how the electric field should be. That means what? This A point, this A should push over here and it should coincide with R. Okay, then only it will become the constant graph like this, the uniform charge density. That means we can get a linear dependence of electric field on R only when D is equal to R. Sorry, not D is equal to R. So that means it should become that A is equal to R. Yes, not D is equal to R. Okay, so the C option. Yeah. So what we have seen in this problem that once we understood our passage or our graph, all the problem could be easily solved. Okay, so this was one of the problem on passage based question. We will see you in the next video. Thank you.